Here we have to differentiate tan inverse under root of 1 plus cos x upon 1 minus cos x by 2. Before we go for differentiation, we have to simplify. Here we have under root of 1 plus cos x by 2, which is converted into 2 cos square half the angle, or we can say x by 4. And in denominator, we will get 2 sine square half angle. So this 2 will cancel out and we will get d by dx of tan inverse of cos by sine, or we can say cot x by 4. Tan inverse is our outer function, so we should convert cot in terms of tan. So cot x by 4 can be rewrite as tan pi by 2 minus x by 4. So we can say we just have to differentiate pi by 2 minus x by 4. Pi by 2 is a constant term, so its differentiation will be 0, and differentiation of x by 4 will be 1 by 4. So minus 1 by 4 will be your final answer, which is given in option A. Ta-da! Here we have to differentiate under root of 1 minus sine 2x upon 1 plus sine 2x. If instead of this sine, if we have some cos, then we can easily simplify it, right? So let's convert this sine in terms of cos. So we will get 1 minus cos pi by 2 minus 2x. Similarly, in denominator, we will get 1 plus cos pi by 2 minus 2x. So we can say in numerator 1 minus cos theta will be converted into 2 sine square half the angle, or we can say pi by 4 minus x. And in denominator we have 1 plus cos theta, which can be rewrite as 2 cos square half the angle, or we can say pi by 4 minus x. So here 2 will cancel out, under root of sine square by cos square will become 10 pi by 4 minus x. Now let's differentiate. Differentiation of tan box will be sec square box into differentiation of your box. Now within the box we have pi by 4 minus x. So we just have to multiply differentiation of pi by 4 minus x. Differentiation of pi by 4 will be 0. Differentiation of x will be 1. So your final answer is minus sec square pi by 4 minus x, which is given in option B. Ta-da! Here we have y is equal to under root of 1 minus x and 1 plus x, which will be converted into 1 square minus x square. To remove this under root, let's say we are taking square on both the sides. So differentiate both the side with respect to x. So we will get 2y dy by dx, and on right hand side we will get minus 2x. So this 2 will cancel out and we will get y dy by dx is equal to minus x. If we multiply y both sides, we will get y square dy by dx is equal to minus xy. If we substitute value of y square, which is 1 minus x square on the left hand side, we will get 1 minus x square dy by dx is equal to minus xy. Take on the left side, we will get plus xy is equal to 0, which is given in option B. So ta-da! Here we have to differentiate cot square x minus 1 upon cot square x plus 1. Before we go for differentiation, let's simplify by converting into cos into sine. Your cot square is simply cos square x upon sine square x. Now, for further simplification, we have to take LCM. So we will get cos square x minus sine square x upon cos square x plus sine square x. So in numerator, cos square x minus sine square x will become cos 2x, and in denominator cos square x plus sine square x is simply 1. So we don't have to worry about this 1. We just have to differentiate cos 2x, which is minus sine 2x, into coefficient of x, which is 2. So minus 2 sine 2x is your final answer. Ta-da! If fx is equal to x tan inverse x, then we have to find out f dash 1. And for that, we have to differentiate with respect to x. We have to apply multiplication rule. Your x will be as it is. We have to differentiate tan inverse x, which is 1 upon 1 plus x square. Plus, in second term, your tan inverse x will be as it is. We have to differentiate x, which will be 1. Now, let's substitute x is equal to 1. So, we will get f dash 1 is equal to, just replace your x by 1. 1 into 1 upon 1 plus 1 square plus tan inverse of 1. So here we'll get 1 by 2 plus 3 pi by 4, which is given in option B. Ta-da! If y is equal to log x base 10 plus log 10 base x plus log x base x and log 10 base 10, then we have to find out dy by dx. Before we go for differentiation, we have to apply property of log. This log x base 10 can be converted into log x upon log 10 plus your second term will be log 10 by log x plus third term will be simplified as log x upon log x, or we can say it will become 1, and similarly log 10 base 10 also become 1. So we are ready for differentiation. We can say dy by dx is equal to, in first term, log 10 is constant term. We don't have to worry about it. Differentiation of log x will be 1 by x. In second term, log 10 again as it is. Here we have differentiation of 1 upon log x, or we can say log x raised to minus 1. So its differentiation will be minus 1 box raised to minus 2, and within the box we have log x. So we have to multiply differentiation of log x, which is 1 by x, plus differentiation of rest of the two terms will be 0 because it's a purely constant term. Now let's simplify. In first term we have 1 upon x into log 10, and in second term we have minus log 10 upon x log x the whole square, which is given in option A. Ta-da! If y is equal to b cos log x minus n raised to n, then we have to find out dy by dx. Now, before we go for integration, let's apply the property of log. Within the cos, we have log x by n raised to n. According to property, we can say this n, which is power in the x by n, will go within the multiplication of log. So now we have y is equal to b cos n log x by n. To get dy by dx, we have to differentiate both the side. B is constant and cos is the outermost function. So let's consider rest of the function within the box. Differentiation of cos box is simply minus sine box into differentiation of box. Within the box we have n log x by n. So we have to differentiate n log x by n. Here your n is constant, we don't have to worry about it. Differentiation of log box will be 1 upon box into differentiation of box, and within the box we have x by n. So we just have to multiply differentiation of x by n, which is 1 by n. So here your n will be cancelled out and we will get minus b n by x sine n log x by n, which can be rewrite as log of x by n whole raised to n, which is given in option C. Ta-da! Here we have to differentiate sin x raised to n into cos nx. And for that, we have to apply multiplication rule. Let's say in first term, your sin x raised to n will be as it is. We have to differentiate the second term, which is cos nx. So differentiation of cos nx is minus sin nx into coefficient of n, which is n, plus your cos nx will be as it is. Now we have to differentiate your sin x raised to n. And for that, we have to consider box around the sin x. So differentiation of box raised to n will be n box raised to n minus 1 into differentiation of your box. And we know that within the box we have sin x. So we just have to multiply differentiation of sin x, which is nothing but cos x. For further simplification, we can take sin x raised to n minus 1 into n can be common. So from first term, remaining term will be 1 power of sin x and minus sin nx. And from second term, remaining terms are cos nx and cos x. So your n sin x raised to n minus 1 will be as it is. And in this bracket, we have cos alpha cos beta minus sin alpha sin beta, which can be converted into cos alpha plus beta, or we can say nx plus x. And to get the proper option, we can take x common. So we will get n plus 1x. So tada! Here we get our final answer, which is given in option A. If fx is equal to log x base x, then we have to find out f dash x at x is equal to e. So before we go for differentiation, let's simplify. We will get log x base e upon log x. Now we are ready for differentiation. So we will get f dash x is equal to, we have to apply division rule. In division rule, in first term, your denominator will be as it is. We have to differentiate your numerator, which is log x. Let's consider box around the inner log x. So differentiation of log box will be 1 upon box into differentiation of your box. Within the box, we have log x. So we have to multiply differentiation of log x, which will be 1 by x, minus in second term, your log x will be as it is. We have to differentiate your numerator, which is log x. So its differentiation will be 1 by x whole divided by square of the denominator, which is log x. Now, in further simplification, your log x will be cancelled out and we can take 1 by x common. So in numerator, remaining terms are 1 minus log of log x whole divided by log x the whole square. So we get our simplified f dash x, but we have to find out at x is equal to e. So let's substitute x is equal to e. So we will get f dash e is equal to 1 upon e, 1 minus log of log e upon log e the whole square. So log e is 1 and log 1 is 0. So finally we will get 1 upon e, which is given in option B. Ta-da!